Hi, my name is Rodolfo from MiningMath. In this video, I'm going to explain step by step how to calculate the block's economic values, and I'll give explanation about how these parameters can strongly affect your mining project. So first, let's begin with the concept of economic values. Every block must have an economic value for each possible destination, which are the processing plants and waste dumps. This field will report the value of each block as a function of its destination, grade, recovery, mining costs, transportation, processing, selling costs, and prices, among others. Then, SimSched will decide based on these values whether and where each block should be processed, discarded, or stockpiled, choosing the one that contributes to maximize the NPV of the project, given all the interrelated constraints from the scheduling optimization. In the case of SimSched Direct Block Scheduler. To calculate the economic values, we are going to need the following formulas, which are separated in 3 steps. On the first step, the block tons is calculated, and then you move on to the next step where you calculate the metal masses, tons copper and mass of gold. By knowing this data and with the complement of other parameters of the model, you will be able to calculate the economic values on the final step, which are the economic value for process and economic value for waste. This is a simple calculation for the gold-copper margin deposit, but the block values could be calculated with any complexity that the user might want to consider, like considering recovery curves, variable costs, and etc. This table presents the required parameters that we're going to use to perform the calculation in this example. So let's move on to the spreadsheet. This data is from margin block model, and we're going to complete the economic value fields that are missing. So first, we need to complete the block tons. Then, the next step is to calculate the tons of copper present on each block, which is copper grade divided by 100 times the block tons. Then, you will do the same for gold in grams. So, with the data that we have so far, we can start the calculation of the economic values. Therefore, for the process, we can start typing the formula. Then you go, after calculation you have here economic value process, then you double click here and then you have for all blocks. For waste, the formula is simpler, so we just multiply minus the block tons per the mining cost. And here, economic value waste for all blocks. Keep in mind that a block value will always be negative if it is directed to a waste dump, as it will bring no revenue, just costs. After the calculation is finished, I took this screenshot to exemplify how the simplest pit optimization process will interpret these results. So I separated these 2 highlighted blocks. The first one will be directed to process, as it has its value bigger than waste. However, the next block won't have the same destination, as it's more reasonable to send it to the waste dump. Note that no cutoff grade has been established, and this parameter won't be required prior to run the software. SimSched will do the work to bring the final feed, sequenced period by period, with optimized cutoff grade and no geotechnical errors. However, for scheduling optimization, decisions may also include multiple processing routes, reproduction constraints, stockpiles, and blending in future versions. So it's not possible to predefine the destination of each block by simply taking the highest value available among the possible destinations. For example, the optimizer could decide to stockpile an OR block with marginal value, instead of sending it straight to the process, in order to process another block with higher value. Thanks for watching this video. For further information, please access our website or send your question to our support service. Links can be found in the description of this video. Best regards, and see you next time.